Okay, in section 11.4, we're going to get into equations in quadratic form. And it starts off with a review for solving rational equations and equations containing radicals. You know, I wrote down a few things here, but we've got to, when it comes to solving anything with rational numbers, we want to multiply everything by the LCD, so the least common denominator. And another thing I didn't write down, I just thought of this, we might have to use the square root principle. And then I wrote in here quadratic formula with a question mark kind of by it, because it's kind of up to you. I mean, if, when you get to the point where it's in standard form, as a polynomial, it would be okay if you kind of solve it any which way. I'm going to probably stick with quadratic formula since that is what we're covering in this chapter. But, if you do find that factoring is something that it's kind of just staring at you, like just start factoring it, go ahead and do that. So let's look at the first one here. The first problem here, the LCD, is going to be pretty much just everything in the denominator. We've got an x, we've got x plus 1 and a 3, so it's going to kind of put it all together. So the LCD is 3x and then x plus 1 in parentheses. So that's what everything's going to end up getting multiplied by. So you really want to kind of focus in on the denominator when you do that. Okay, so this x right here cancels with that x, and we're left with 4 and 3, which makes 12. So I've got x plus 1. This x plus 1 cancels with this x plus 1, and then what's left for that one is we've got negative 11 times 3x. And then this 3 cancels with that 3, and we're left with what? We're left with 8 times x, and then x plus 1. This step right here, let's go ahead and just start clearing parentheses. So 12 times x is 12x plus 12. 11 times 3x is going to be minus 33x equals 8x squared plus 8x. And like terms on the left side, which I'm going to clean up, so I've got 12 minus 21x equals 8x squared plus 8x. And then I'm going to get everything to the right. I'm kind of in the habit of making sure the leading coefficient is positive. However, with quadratics, it's not necessary that you have the leading coefficient positive, but just kind of out of habit, I'm going to do that. So I'm going to bring everything over to the right side. So I'm going to bring over 21x. That's become 29x when I add it to the 8x. And please excuse me if I'm doing a lot of mental math, but these problems are long, so I just want to kind of break it down into as few steps as possible. All right, so now we have all the necessary ingredients for the quadratic formula. So we've got our A is 8, our B is 29, and our C term is negative 12. So now I'm going to go to the quadratic formula, and I'm going to do what I was doing before, which is I'm going to put in parentheses wherever there's a letter. Okay, so now after all that, we've got our two solutions, which are 3/8 and negative 4. And one thing I want to be careful with, especially on this one, is you've got x's in the denominator, so we're going to look for erroneous possible solutions here, and it doesn't look like anything's erroneous, because right here, if we put let's say we put a -1 there, then yeah, that would make the denominator 0. So I think these answers are perfectly fine. On example number 2, we've got our LCD. Our LCD on this one is going to be 18b. So that's what everything is going to get multiplied by. So 18b, this is going to get multiplied by 18b. 18b, this b cancels with that b. Now this 3 turns into 1, and this 18 turns into 6. So now we're left with b times b, which is b squared, minus 4 times 18. Now 4 times 18 is 72. So minus 72 equals, and then 1 times 6b, which is just 6b. So you got b squared minus 6b minus 72 equals 0. And this is what I was talking about. Like, I mean, if you want to go ahead and use the quadratic formula, a is equal to 1 and b equals -6 and c equals -72, you can go through that process if you want to. I'm comfortable enough, maybe you are too, I'm comfortable enough with using the product sum method and just kind of factoring that out and seeing how that comes out. I can just do this. And so that 72 is our product. So the 72, and if you don't know those off the top of your head, you can just kind of write them up. But you got 1 and 72, 2 and 36. We've got 3 and 24. We have 4 and 18. 5 does not work. 6 and 12 works. And then, of course, 8 and 9 makes 72. Okay, so what pair of products, or factors I should say, will make 6? And it looks like it's going to be 6 and 12. So 6, we want to make -6, so I'm going to use -12 and +6. And like I said, see, that's much easier than using the quadratic formula. If you can avoid using the quadratic formula, do so. Avoid it. You don't have to use it. It's a lot of work, and it can get messy. So that b equals 12 right there, and then you got b plus 6 equals 0, and then b equals -6. And there it is. Just kind of look at those answers there and see if anything there makes anything undefined, and it doesn't. All right, for number 3, we don't have to find an LCD. We just need to solve this. So for this one, let's get the square root isolated. So let's isolate that. So we're going to have to move over the non-square root. So you have root d equals 20 minus d. And the purpose for doing that is now because now you can square both sides. And then when you square a square root, you get, that just becomes d. And this becomes 20 minus d squared. That's going to involve just a little bit of multiplication. But remember, when you're squaring a binomial, it's not just 20 squared and d squared. It's not ever going to work out that way, ever. So you're going to do this. That's 400. That's minus 20d. That is also minus 20d. And a negative times a negative is positive, so that becomes positive d squared. Sorry, that looks like an a. D squared minus 40d plus 400. And then let's get that d over. So now you got 0 equals d squared minus 41d plus Okay, so for number 3, we've got our two solutions. We got 25 and 16. And I'm going to go ahead and check those. Let's make sure they both work. And I'm going to put in 25 first for D and see if that's a viable solution. See if it makes it true. And I want this side to equal 20, right? So you got 25 plus the square root of 25 is 5. And that does not equal 20. So 25 plus 5 is 30. That does not work. So you can throw out 25. 25 is that's an erroneous answer. It's a non-true answer. All right, let's try 16 next. I'm betting that will work, but let's just make sure we are thorough and we check it. So you got 16, right, and then plus root 16. See if it equals 20, and it does. So 16 plus 4. I mean, it's really plus or minus 4, but I just want to see if I can get 20, and I do. So 20 is the only viable, or not 20 is, but 16 is our only solution to that particular quadratic. All right, for number 4, we're going to do something pretty similar. So let's get the square root all by itself. Square both sides. So there you have it. W equals 13 on that one. And if you want to check that out, let's make sure that works. 13 plus 3, and then there's a plus 7 outside of the radical. So 13 plus 3 is 16. And 16, the square root of 16 is 4. 4 plus 7 equals 3. That is false for sure. Okay, so let's just do number 5 here. We've got, I'm going to let the letter U represent the x squared term, and we're going to say U squared represents the x to the 4th term. Okay, so we're going to rewrite this with those substitutions in play. U squared minus 29u plus 100. Do this. And 100, 100, if we look at all the factors of 100, it's 1 in 100, 2 in 50, 3 doesn't work, but 4 does, 4 in 25, 5 and 10, 6, 7, 8, 9 don't work, but 10 and, all right, what did I put 5 and 10? I meant 5 and 20, and then 10 and 10 work. The pair that is sticking out at me is the 4 and the 25. Now we need to make those into negative 29, so they're going to both be negative. The first one is going to be 4, and the other one is going to be 25. Okay, but we can't stop there. We have to kind of go back to the substitutions that we made, and we have to kind of just put those in. We have to resubstitute them back into what we took out. Our first one we're going to do, we've got u equals 4, and I think I have the arrow pointing in the wrong spot. I want to substitute that one into there. 4 equals x squared, and then you can solve that by just doing the square root of both sides. And so this is going to be plus or minus 2 equals x. So there, I know that looks like one solution, but that's actually two solutions. We have positive 2 and we have negative 2. And then let's put 25 into that equation as well. We do 25 equals x squared, do the square root of both sides, and you get plus or minus 5 equals x. So there's your solution set. You've got positive 2, you've got negative 2, you've got positive 5, and you've got negative 5. We've got 4 possible solutions there. And that makes sense because this has got a degree of 4. So there should be 4 solutions. And you know what? I'm going to stop there because I'm never going to give you that on a test, and that was pretty much like what we just did.